Okay, guys, the next lesson is on the volume of pyramids and cones. So here, once again, we've just got a formula we've got to use. I believe this one is on your formula sheet, and it's very similar to the formula for a prism. Obviously, the formula for a prism is the volume equals the area of the base times by the height. In this particular case, we do that, but we multiply it all by a third, because if you could imagine a prism, like a cylinder here, this cone ends up taking about a third of the space that the cylinder would take up around it. Not about, exactly a third of the space that it would take up around it. In standard maths, we don't have to prove that's the case, we just have to use the formula. Okay, so to calculate the volume of this cone, we're going to need the area of the base, and we're going to need to multiply it by the height, and then we're going to have to multiply it by a third. So once again, let's start by putting in our formula, which is a third of the area of the base times the height. And I'm actually going to write that out again, and I'm going to expand on what it means to be the area of the base, because we're talking about a circle here. So the area of a circle is pi r squared, and then we're multiplying that by the height. Okay, so we can now just substitute in the values we've got in our equation. So a third and pi, they're just numbers, we can just plug those in. Now, over here, this isn't the radius, that's the diameter. So I'm going to have to halve that to find the radius. So half of 12 is 6, so we're going to be multiplying by 6 squared, and then we're going to multiply that by the height, which is 10. So we plug all that into our calculator, which I'll just grab up there. So 1/3 times by pi times by 6 squared times by 10. So 376.99. I'm going to round that to the, because it's so close, I'm going to round that to the nearest millimetre and say it's 377 millimetres squared. Okay, so you can see it is just the case of using that same formula again. We still need to know the area of the base, we need to know the height, we just have to remember to multiply it by a third. So this formula applies for cones, but also applies for pyramids. So thankfully, this is nowhere near as difficult as finding the surface area of a pyramid. We just need to know the height of the pyramid. In this particular example too, everything's in centimetres, so I can just pull out that formula. Volume equals area. Oh, sorry, I forgot the third, so we'll just go backwards. Volume equals 1/3 of the area of the base times the height. Now in this case, the shape on the bottom is a rectangle. It's 5 by 4 centimetres, and it says here it's a rectangular pyramid. So it's going to be a third of the length times the width, still times by that height. So that's going to be a third of 5 times 4 times 9. And once again, if you can do that in your head, that's all fantastic, but it's just as easy to pull out the calculator and we can write all that in there. So 1/3 times by 5 times by 4 times by 9 gives us the answer of 60. And that's all there is to that one. Now 60, our units are centimetres, so we are in centimetres cubed. And with that, I have realised a mistake I've made up here. I've put this in millimetres squared. In that first question, it's actually millimetres cubed. So I'll just grab my eraser there and I'll fix that up. Oh, pen is not being very happy with me right now. There we go, cubed. All right, so just because we're after volume, everything should be cubed. Area is squared. So the next one is the volume of a truncated pyramid if its original height was 12 centimetres. So we had a question like this the other day that was a little bit more complex. This one, because they give us the height of the original pyramid, what we can imagine is Well, at this point here, sorry, pen issues. At this point here, we can imagine that there was a pyramid still going on that sits sort of on top. Okay, so if we find the volume of this top piece and then volume the volume of the whole thing minus that top piece, we'll be able to get the volume of this pyramid. So just to make that a little bit clearer, so the volume of the full pyramid minus the volume of the top piece, I'll say. All right, so once again, the formula is the same, 1/3 of the area of the base times by the height of that first minus that 1/3 of the area of the other, the top piece times by the height. So that's going to give us the volume of the full pyramid if it was all there. That'll give us the volume of the little top piece, and the full formula will give us the volume of the bit that's left over, the truncated pyramid. So for this big pyramid, we've got 1/3 times the area of the base. Well, it's a square pyramid because its dimensions are given as 4 by 4 down the bottom here. Sorry, where's my little mouse gone there? So yes, we've got the dimensions of the base are 4 times 4. So we've got a square pyramid. So we can go times by 4 by 4, or we can go times by 4 squared. And the area of this little top piece, oh, sorry, and I've forgotten the height. So it says the original height was 12 centimeters. So that's actually what we're going to have to go with here. Okay. And then what we're interested in now is this little top piece. So once again, 1/3, the area of the base of the top piece, well, they've given that here. Where it's been cut off, it's a square 2 centimeters by 2 centimeters. So I can find the area of that base by just going 2 squared. And its height is this full 12 centimeters of the whole pyramid that was there, less the bit that's still left. So it's 12 minus 6, so that's going to be 6 centimeters left. So if this was 6 centimeters here and the thing was 12 centimeters to begin with, then this part here that's been cut off must also have been 6 centimeters tall. Okay, so we just plug that into our calculator. I'll find the mouse easier for that. So 1/3 times by 4 squared times by 12, and we're going to minus from that. We can put this all in the calculator at once. 1/3 times by 2 squared times by 6. All right. So as long as you're nice and careful with how you put in the calculator, it will work out for you. And so we end up with a area of 56 centimeters, and this time I will remember that we should be writing cubed because it's a volume. All right. So the next question is from the 2015 HSC paper, and it's regarding the Louvre Pyramid in Paris. I don't know if anyone's been there. It's quite an interesting thing to look at. So it has a square base with a side length of 35 meters and a perpendicular height of 22 meters. So what is the volume of that pyramid to the nearest meter cubed? So once again, let's just use that formula. The volume of any pyramid is going to be 1/3 of the area of the base times the height. Now, in this case, they said it's square base, so obviously that's 35 times 35 is going to give us the area of that base. So all 35 squared. And then we just multiply that by 22, which is the height of the pyramid. And again, we just plug that into our calculator and see what happens. So 1/3 times 35 squared times by 22. Now it's given me an answer as a fraction. I don't really want it as a fraction. I'd rather get a decimal. So if I press the fraction to decimal button here, that'll give me my area, which is 8983.3. And we're in meters cubed. And I asked to the nearest meter cubed, so looking at that, we're going to have to keep it the same when we round. So this guy here is clearly the correct answer. And the final question we've got here is a rectangular pyramid has base and side lengths of 3x and 4x, and the perpendicular height is 2x. All the measurements shown in meters. What is the volume of the pyramid in cubic meters? So although this just throws a bit of algebra in here, it asks you to understand what's going on with your algebra, I guess. But the formula is still the same. So the volume is that area of a third of the area of the base times by the height. Now, the area of the base in this case, being a rectangle, is just length times width. So our length was 4x, our width is 3x, and then we've got to multiply that by the height of the object, which is 2x. So you can work this out however way you want to. You could look at a third of 3 is 1 and then just go, well, 1 times 4 times 2 is 8. Or you could work out 4 times 3, which is 12, and multiply that by 2 is 24. A third of 24 is 8. You could even use your calculator for this one. Just ignore the x and plug a third times 4 times 3 times 2, and it will still give you the value of 8, and you'll just have to remember to leave the x cubed on there. All right. So although that's quite confusing with the algebra in there, you can see that once you start plugging the information you have into the formula you're given, it works out reasonably easy to the answer to the question. The trick here would be not to form the habit of going 4 times 3 times 2, which would give you 24. That would mean you're disregarding this 1/3 out the front. And I think that's the last question for this lesson. Yes, it is. So hopefully you enjoy Thursday with Mrs. Burns, and I will see you guys on Friday. I'll put up one more lesson if I get time tonight, which will be for the second period of tomorrow. Cheers.